right, the last part of 6.2 is looking at a special type of application, which we've already done, the marginal analysis with single variable functions. And so now we're going to look at marginal analysis for multivariable functions. All right, so remember, it works very similar to what we did previously. Remember, marginal analysis is using the derivative to talk about approximate a change in the function, and specifically a 1-unit change. All right, we're looking at a 1-unit increase. And the biggest part here is because it's multivariable, which variable are we changing? All right, so when I take a derivative, I either change it in the x direction or, not and, or the y direction, so one or the other. All right, so either I'm looking at the marginal analysis of the x, or I'm looking at the marginal analysis of y. All right, so the first example is just going to kind of give you one where you can look at the different cases in sort of a multiple choice format, so you can kind of pick out the right answer, because there's 3 parts to it that we look for. All right, so we have a company. They sell 2 different kinds of pools. All right, they sell a 24-foot pool. That's the x value, so the x represents the 24-foot pools. Y is the slightly smaller pools at 18 foot. All right, so there's 2 sizes, 24-foot and 18-foot. All right, f of x represents the profit in dollars, so that's what the f of x represents. And so we don't have it. What we have is the rate of change function, and specifically this is the function we're given with this information. And so we'll find the first derivative with respect to x. All right, so x is the variable that's changing. When x is at 500 and y is at 200, or 120, when we plug those values into that first derivative with respect to x, the value that comes out is 1500. And so there are 3 parts to this that we're looking for in the marginal analysis interpretation. Remember, marginal analysis, the interpretation is just as important as getting to the right answer, especially in this multivariable case. All right, and so what we're looking for is what variable is changing, what variable is being held constant, and at what level, because it matters, and how is it affecting my overall function. All right, well, it's the x value that's changing, that's being held constant, and this is how profit is changing. All right, and so remember, the one that changes is changing by 1 unit, and it's specifically looking at 500 to the next one, so 501. And so I'm looking for, well, when I go from selling 500 to 501 24-foot pools, I hold the 18-foot pools constant at 120. It matters that it's 120. If I had a different constant, I'd get a different number. When that happens, when those 2 things happen, profit will go up by about $1,500. And so I look through my descriptions here and we pick out the one that's the best answer. Well, the first one is telling me profit when I sell this many and this many comes out to, and so that's wrong, because that's not what this is finding. It's finding a change. Right, nowhere in there does it say change. All right, so A is wrong. All right, B, the 24-foot pools are being held constant. Well, that's false. That's not what's being held constant. That's one that's changing, and so that's false. All right, C, the 24-foot pools are increasing from 500 to 100. All right, so far that's what we're doing. The 18-foot pools, that's supposed to be 18-foot pools, are being held constant at 120. When that happens, profit increases by 15. All right, so that one's looking good. All right, but I'm going to read the rest of them to make sure that's the best choice. All right, D, 24-foot pools are being held constant. Well, that's false. They're changing. 24-foot pools are changing by 1 unit. 18-foot pools, it says, are changing, so that's false, because 18-foot pools aren't changing. They're being held constant. All right, so C is my best option. All right, C is the correct choice. Again, that needs to be an 18 in there, but C is the correct choice. The 24-foot pools are going up by 1 unit. Specifically, 500 to 5, that 1. When I make that specific 1 unit change from 500 to 501, when we hold the sale of the 18-foot constant at 120, when those 2 things are happening, profit isn't 1,500. Profit is increasing by 1,500. We're adding 1,500 more dollars to whatever the profit was at our previous sales. All right, so again, that's the three parts that we're looking for. All right, so the next example, we're now going to practice writing one of those out. All right, so example number 2, we have a hardware store. All right, it has two kinds of hammers. All right, they sell the first brand for X dollars, so X represents dollars of the first brand. The second brand is sold for Y dollars, so Y represents the price of the second one. The monthly profit in hundreds of dollars, so gotta keep in mind it's hundreds of dollars, is given by PXY. Interpret the meaning of. Alright, so it's P sub Y, 27 for X, 10 for Y equals negative 4.5. Alright, that's the piece of information I'm given. I don't know what the profit equation is. Alright, they gave me a derivative with respect to Y. So the first order derivative with respect to Y. When we plug 27 in and 10 in, we get out negative 4.5. Alright, now, again, like I said, the analysis part is the big part about this. The interpret the meaning in terms of analysis. And so what's happening here is what's changing, what's being held constant, at what level, and how is it affecting my overall function. Alright, well, it's the Y value that's changing. Alright, the Y value is the 10, which represents the second brand. So if we increase the price of the second hammer from, well, it was selling at $10 to $1 more, so we increased it, specifically that increase. We were selling at 10, but we're going to increase it to 11. And we hold the price of the first type of hammer constant, meaning we don't change it at all, specifically at $27, right? That's what it's being held at. That's what they're selling them at. When those two things happen, profit will decrease by, remember, it's in hundreds of dollars, so it's not $4.50. Remember, this is in hundreds. All right, so you can either write 4.5 or you can multiply by 100 and say 450. All right, I'm going to say it's decreasing by $450. All right, so we will be, and it should make sense. We're going to lose profit. They're going to sell fewer hammers. All right, when they increase price, fewer people will buy it. So fewer people buy it, profit drops. All right, and this is how much, based on, again, it's a prediction, based on the marginal analysis is what they're going to predict happens. All right, but two things have to be true. This is changing by 1 unit. This is being held constant specifically at that value. All right, the next example we're going to kind of set it all up. All right, so the first one is fine. So we've got a company that produces two styles of baseball uniforms, a modern and a throwback. So X represents the modern, Y represents the throwback style. All right, this is my equation for profit. And so the first one, there's no derivative. It's just the profit at my X value 125, my Y value 20. And so you just make sure you're really careful. There's a lot of parts here. Make sure at the X part you plug in 125. The Y parts, make sure you plug in 200. And when you write it out, it's a dollar amount. And so just, the biggest thing about this is these equations are complex. And just make sure you're very, very careful when you're plugging it into the calculator. Alright, so when I plug it in, I get this is 353750. Alright, and then what does it mean? Right, so that means the profit is exactly 353,750 when they sell exactly 125 modern and 120 throwback uniforms. Alright, so that's the profit that they're currently at. Alright, so when they're selling 125 of the modern, 200 of the throwback, that's how much profit they get. Alright, so part B. Find the first derivative and clearly interpret its derivative. So find the first derivative with respect to X. Plug in your current level of cells, 125 and 200, and then interpret its meaning in terms of marginal analysis. Alright, so our derivative with respect to X. derivative with respect to x first is going to come out negative 4x, zeroes out, 30y, 200, the rest zero away. Alright, so there's my derivative with respect to x. So now I plug in my values. My derivative with respect to x at 125 and at 200. Alright, so make sure you're just careful. Plug in the right x value and the right y value. Excuse me. It comes out to 5,700, which again, that's the find part. Now the interpret, which the interpret part's the more important part. All right, and again, finding that was the function's derivative and the value, was the important part, but the interpretation is what we're looking for in this as well. All right, so what's changing, what's being held constant, and how is it affecting my profit? And so the x value is changing, and so if they increase the sale of modern, specifically from 125, remember it's a 1 unit change, from 125 where they're at to 126, and hold the throwback sales constant, not at any value though, it's a specific constant because I actually used it, right, at 200. Alright, so they have to have those two things be true. Profit will increase by 5,700. Alright, so those are the three parts we're looking for. What value is changing, by what amount, it matters. What's being held constant and at what level, because it mattered that because I plugged 200 in. So had this been constant at 100, I would have got a different answer out. So it matters that it's constant at 200. So that's important to put in your answer. All right, the last part of this. Derivative with respect to y at my current level. All right, so derivative, so I go back up here and find my derivative with respect to y. All right, so those are my y parts. So the derivative with respect to y is going to come out negative 24y. To y, in case you can't read that. 30x and 700. So plus 30x plus 700. I'm going to write my y a little nicer. Then you plug in your value. They're currently selling 125x, 200y. Make sure you're careful. It's negative 24 times 200 because that's the y part. 30 times the 125, that's the x part. 700, and so that value comes out negative 350. Alright? And then so now the interpret part. Alright, so there's three parts to the interpretation. What's changing, what's being held constant at what level, and how is it affecting my overall function. Alright, so if they increase the sale of the y value, which is the throwback, from 200 to 201, not 2001, 201. Alright, so that specific change in my throwback, hold the modern sales constant, not at any constant, specifically at 125, right? That's what I used it, right? I plugged it in, right? So I used it. Profit will decrease by 350 because it's negative. All right, so those are the three parts we're looking at. What's changing? What's being held constant? At what level? How is it affecting my overall function? All right, I'm going to look at one more example. All right, I'm going to look at problem number 42, which is a special type of equation called the Colby-Douglas model. And again, if you take an economics class, these are models that are often used for labor and capital in an economy. All right, and so we're looking at the Colby-Douglas model. All right, so here's sort of the generic case. X represents the number of units of labor. Y represents the amount of capital. So labor would be the people that you're paying. Y would be the capital, so it'd be your buildings and your machinery and those types of things that you're spending your money on. Alright, so we're going to use this one in our particular problem here, problem number 42. Alright, so this is problem number 42 from the book. The equation that comes out, or the equation that was given, was P of xy. Alright, 2400, x raised to the 2/5, y raised to the 3/5. P is the number of units of production, alright, how many items they're producing. X is how much labor, and y is how much capital they're putting into it. Alright, so they would represent whatever units that would be on labor dollar amount or a unit amount. Alright, so find the P. We have 32 units of labor and 1,024 units of capital. Alright, so, and then B is marginal productivities. And then evaluate it and interpret. Alright, so A first. A is just find it at X and Y. So find our productivity when X is 32, Y is 1,024. So this is just plug it into that equation. And make sure you're careful, those are fractional exponents. So when you raise it to the 2/5, good idea to write parentheses around it. And the 3/5. Alright, so make sure you're careful when you plug that in. And so it comes out 614,400 units of productivity. Alright, so there's A. B, find the marginal productivities with respect to both variables. That means find the derivative with respect to both. So I'm going to find the derivative of the productivity with respect to X, and find the derivative of the productivity with respect to Y. Alright, so with respect to X, X is the X to the 2/5, so that's the part I'm going to take the derivative of. So the 2,400 and the Y to the 3/5 comes along. I take the derivative of the X part. The X is X raised to the 2/5, so first thing I do is pull out the power 2/5. X raised to the 2/5 minus 1, which is going to give me a negative 3/5. Alright, then I will clean that up. I can take my 2/5 times my 24. If I take 2/5 times 24, it comes out 960, and then I just rewrite it. And you can leave it xy or yx. I like my x value first, so I'm going to write my x value first. X to the 3/5, y to the 3/5, x to the negative 3/5. Make sure you put the negative on the 3/5 of x. Y to the positive 3/5. Alright, and so there's my marginal function with respect to x, and now I find my marginal function with respect to y. So again, going up here. Now it's the y part that I take the derivative of. So the x parts come along and the 2,400 comes along. So 2,400 x to the 2/5, derivative of the y. Power rule, pull out my 3/5, y raised to 1 degree less. So 3/5 minus 1 is going to leave me with a negative 2/5. Clean that up. 2,400 times 3/5 is going to come out to 1,440, x to the positive 2/5, y to the negative 2. And there's a reason why. Again, we don't go into it. There's a reason why there's a relationship between labor and capital and productivity. And again, we're just kind of practicing the math of it. We're not going to go into the whys. You would take, again, another class to talk about that. But notice the pattern here. All right, the variables are raised to the same degree but the opposites, right? And this, with respect to x, x is my negative 3/5, y is my positive 3/5. With respect to y, x is my positive 2/5, y is my negative 2/5. And there's a unique relationship between the two, and in terms of capital and labor, which again, the relationship was what the Colby-Douglas model kind of represents. We're just going to find it. We're not going to really go into the why or how of it. All right, so there's part B. Marginal productivities. And then C is evaluated at our current level, 32 units of labor, 1,024 units of capital, and then the last part is explain the answer. All right, so C is find our level of productivity, our marginal analysis at our level of productivity. All right, so P sub x, when I've got 32 for x, 1,024. Again, plugging it into that equation. Just make sure you're careful with your exponents. Good rule of thumb is to put parentheses around it. Alright, so when I plug those values into my derivative with respect to x, it comes out 7,680. Okay, and then with respect to y, same xy, but different function. All right, so again, that's going into that function. All right, make sure you're careful when you plug it in. 360. All right, then the last part is to, well, what is that telling me? So there's two interpretations. So I'm going to start with the x interpretation, and then I'm going to end with the y interpretation. All right, so the productivity, what's changing, what's being held constant, and how is it affecting my overall function? So x is changing, x represents the labor, y represents the capital. Just remind myself what they represent. All right, so in the first one, so again, I'm interpreting the x first. All right, so if they increase capital from 32 to 33 units, hold labor at 1,024 units, productivity increases by 7,680 units, which is a pretty good increase. All right, that might not be a bad thing to do. All right, so those are my interpretation of the first one. Now I'm going to interpret the y part. So underneath that, all right, maybe not underneath that. So I'm going to erase it, and then so there's x. So hopefully you have it. So again, the interpretation of the x part is x is changing, which is my capital changes. So we increase capital from 32 units to 33. Labor is constant at 1,024. What that does, it increases my productivity by 7,680. All right, so now I'm going to do the other one. So I'm going to erase this because I didn't really have enough room to write it underneath. So I'm going to erase it and write it here. All right, so now interpreting this one. All right, so what's changing is the y part. So if we increase the labor, right, the y part is the labor, specifically from 1,024 to 1,025 units, hold capital constant, specifically at 32 units, productivity will increase by, you can read that, will increase by 360 units. All right, so we're still increasing, but we're increasing by less in the y direction. All right, so a labor unit didn't give us quite as much as a capital unit did. All right, so again, comparing the two. Alright, so we're going to finish up there. I know there's another problem on there, but this one was harder than I intended it to be, so we're actually going to skip this. Don't worry about it. I won't ask anything like it on the test. And so we're going to stop that. That's where we're going to stop the set of notes. Alright, so marginal productivity.